Hey guys, welcome to Satisfactory Design, where we help you build wonderful looking bases that your friends are jealous of. And in today's episode, we're going to start with something as simple as reinforced iron plates, because it's one of the first things that you start off with that you got to manufacture, so we might as well go strong with this. So if we come over here in the hub, we can see that the reinforced iron plates are in Tier 0, upgrade number 3. But unfortunately, we can't make a factory with the reinforced iron plates only getting this far. We actually have to go further. We actually have to go all the way to Tier 2 in part assembly to get the assemblers just to make it. Not to mention, we're going to need Logistics Mark II, so we have the Mark II conveyor belt. So if you get everything unlocked all the way to Tier 2, you're ready to go with this wonderful build. So with everything unlocked in the hub, you're going to want to actually research what you need to make this. So I made this little R&D section to make it a lot easier for both of us to figure out. So if we come over here, you can actually see that the reinforced iron plates are just iron plates and screws mixed together. Now, to get a better understanding of what you're going to need, I actually made something for this. So as you can see over here, I made a little spreadsheet that is editable, not edible, you can't eat it, but editable, so you can actually change some of the numbers in the black spots right over here, and it actually changes everything in the nice little equation. So now I will be producing 10 reinforced iron plates per minute, and it'll be 2 assemblers, and this can go up to like 2,000 if I wanted to, pretty much easily and all that kind of stuff. But, of course, we're going to stick with just 2 assemblers. Now, the reason for this is because by the time you unlock Tier 2, everything in that, you're only going to have a pure node at 120, not to mention the belts that can only handle 120. So we're not going to need anything above that. So that's going to be 2 assemblers, 3 constructors making the screws, 3 constructors making iron rods, 3 constructors making iron plates, and 4 smelters making iron ingots. And as you can see how each one is attached and why it is the way it is, it makes it really easy to understand what is going on. Not to mention, these are all base recipe ones. When we get back down to the alternate recipes and you really see the numbers explode, then you get to understand, why we chose the way that we chose. But first off, we're going to stick with the wonderful reinforced iron plates base recipe and build us something nice with that. Alright, ladies and gentlemen, I built this nice little setup over here so you can understand a little bit further on how this is actually set up. So if you want to do this a different way, you're more than welcome to. But the idea is that a conveyor belt Mark II comes in, and that gets split off into 1, 2, 3, 4 smelters. Now the 3 smelters over here are all getting merged together, and they're going over into the 1, 2, 3 constructors over here making iron plates. Whereas this one over here is getting split off into 1, 2 constructors making iron rods, and those are split off into the 1, 2, 3 constructors making screws. And then everything is merged together and then split off half and half for these lovely 2 assemblers. So with the basis out of the way, time to show you guys what a well-designed one looks like. Look at this beast right over here. This is everything that's over there, but oh, so much more. So much more. And as the stuff gets further on down, you will see its greatness. But the idea behind this is that everything is not only OCD friendly to the max. I mean, look at that lovely symmetry, that belt work right there, how everything just loops together in a nice looking pattern and everything. Oh, it's so good. I love it. Not only is it OCD friendly and everything like that, but it is 100% efficient. Everything is at 100% once it actually runs for a while, because we all know that the percentage for efficiency doesn't tend to work right. So how does this work differently from that one? Well, you got the nice splitter that splits it off into 4, which is nice and even, where this one over here had to put 3 off to one side and 1 off to the other, which is a little bit different. So we are a little bit more compact in the way that we're building things, not to mention having this offset a little bit further up kind of gives it that cool look, and it lets you do a nice little straight line with the belt work coming over here. So basically you got 3 splitters, 1 splitter in the middle, then the 2 splitters to take care of these 4 lovely smelters. Then the way that the smelters are set up is it's sending 15 all the way into the middle over here, while sending the rest of the other 15 over here into a merger. So we're merging 1, 2, half of this one and half of that one into one little section, then splitting it 3 ways to 1, 2, 3 constructors. Now the joy of this is because we're splitting it into 3 and everything, it's got that nice even coat and everything like that. So everything is so OCD. Oh, and I did the same thing as I did over there, where I have one of these move just a little bit further back so it works out perfectly going into there. And then these things are merged together, and then they go underneath and sent all the way over here to the end. And that's actually going to send it to a splitter that splits it up and goes into each one of these assemblers. Now, you could go over the top with it, but I wanted to keep the top up with these power lines and everything like that because we could have the power up there. Now, we could have the power on the bottom as well. It doesn't really matter. That's up to you on which one you prefer better. But I kind of liked having the power lines over here because, as you can see, even the power lines are OCD friendly. We have this two taking care of those two, and these two taking care of those two, merged together. As you can see, another one merged here. That's going to take care of this one. And then those are going to be, it just works. It just works. And I'm going to show you how to build all this as well. On to the tutorial part of our nice little example. Now, as you can see here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. A 3x11 setup ready to go just to make everything that we need to do. I also put 2 out here for the extra little bit that's on here, but that's up to you on how you want to go further on that. So the first thing that we're going to need is we're going to grab over here and we're going to grab a splitter. There we go. Now the orange is right in the middle here, and the other orange is right in the middle here. Easy peasy. Next, we're going to take our lovely little smelters. Now see how it's like pretty much all the way matched up to the line? Like if I can't go any further back than that, but I can go further forward. So further back like that. Now for the ones that are over here. So what you're going to do is you're going to grab right up to the edge, and you're going to go 1, 2 back. And just to show you how good that works, look at this. Look at this. Oh my God. Now what we're going to do is we're going to take a splitter, and we're going to put the splitter all the way at the edge right here. Make sure the orange is facing the right direction. So basically, it's going to be as close as possible in a line to this one. Now mergers, you want to make sure that the green is facing inward on this one. The green is facing that way. But then you're going to have this one, the green is facing the other way. And then this one, you're going to have the green facing forward. Pretty easy. And you're going to put the splitter in the middle. And the constructor is lined up perfectly. Then this constructor goes back 1. And that should work out easy peasy. Now let's just grab this nice little belt, test it out, because if it doesn't work, we want to be able to change it. And look at that. It just works, ladies and gentlemen. It just works. But what you're going to need is you're going to need a Mark II in between here. Now the reason for this is only going to produce 30. And then this is going to send you 15, so you're going to get 45. Then you're going to get another 45 over here, that's going to give you a 90. Well, the 60 belt in between here will not happen. So you're going to need a 120 belt to make sure that this is actually split off. So each one of them gets the 30 that they need. Easy peasy. So you can either put the merger really close like that, or if you want to, you can put a little bit further up. It's up to you on how you have it. So instead of having this go right in here, what you want to do is you want to make a little line. Once it's lined up in front of it, go back 2, and then curve it around, and you can get some nice 90-degree lines. What you want to do is you want to grab this lovely monstrosity, which is the lovely merger. Make sure it's aimed forward. Then grab your constructor, and make sure it's perfectly aligned. And this one's perfectly aligned to go forward. There we go. Then we have the nice lines going in. Now, what you could do, this is up to you if you want to do this, take your constructor, and instead of putting it here, you put it 1 more over. And then when you put this on here, you'll have a complete and solid line going across. Though it does hang off a little bit more than that one does, but you know, it's up to you on which one you find is better. Now, in preparation for later, I'm going to delete this ground right here. So grab a splitter, And then we make sure the splitter is to the line. One in the middle. And this one going down one. And this one down one. And then I can grab all my belts and hook up my belts. See, if this was further back, this belt would be, entangled with this machine and it wouldn't work. Basically gonna go right up to it and make sure that it's pointing the right direction. And then we're gonna need a merger over here and make sure the green one is pointing forward. So now we're going to take another splitter and we're going to have this one going the opposite way. So the orange is actually facing forward. And we're going to have it right next to this. Boom. Right like that. And right like that. So as you can see, it had the line that was pointing in between these two. And then... there we go. And connect it again. So now this is coming over and it's getting split, and we just have them split going right into there. Perfect. And we have this going right into there. Perfect. And there we go. Look at that little setup right there. Now, yes, I did have these over a little bit on this one, but having it perfect like that just kind of helps too. It's up to you on how you want to do it. And then the final step. Boom. All right, ladies and gentlemen, and there we go. You're pretty much all set up. Now, the next thing you have to do is you just have to set up power lines. Then you just got to make sure everything is chosen for the recipe and you're ready to go. So all you got to do is set up the recipe, give it actual real power, and then it's ready to go. Now, for those advanced players that actually stuck to the end, I wanted to show you something a little bit more interesting with alternate recipes. Now, the alternate recipes have a lot of different byproducts and stuff that you can actually go through and change up and see what it is. So there are 3 main different alternate recipes for the iron plates. And the way that I set this up is you can actually change the one that you have on here, and it'll change how many different assemblers and pieces and stuff like that. So what you could do is you can actually take out a nice little calculator, and on your calculator you can actually say something like, let's say I want to have 100 iron plates per minute. And I'll divide this by 3.8, so 3.8, and that is 26.315. So 26.315. 315. Boom. So that's going to make 100. Now I can actually see my totals. That's going to use 37 iron ore and 166.5 crude oil. Okay, so the next thing is the bolted iron plates. So if I take my calculator out again, clear this, and then do 100 divided by 15, I can see that that's only 6.666 repeating. So 6.666, that's a lot of sixes. So this uses 153 iron ore and 151 crude oil. So this is going to use, if I can get this actually to be just on there perfect, so this is going to use more iron but less crude oil. Now the final one that we have is stitch iron plates, and this is going to produce 5.6. So we take out our calculator once more and have 100 divided by 5.6. That's going to be 17.857. So we'll put 17.857. All right. And that is going to use 293 iron ore, which is more iron ore than this one, as well as more iron ore than that one. It's going to use 188 crude oil, which is more than that and more than that. Not to mention caterium, copper, and water. Oh my God. So this one right here, total waste. Using wire for it, garbage. This one right here, sure, it uses more iron ore, but less crude oil. So, whichever one. But honestly, this is the best recipe for that. That is the Adhere iron recipe that uses iron plates at 11.25 per minute. And rubber at 3.75 per minute. And the way that I had this going is I have steel-coated plates, which actually use steel and plastic. I have a way to bypass all the plastic and everything like that. So all you really need is some iron ore and some crude oil, and you can have yourself quite a lot. I mean, think of it like this. If you actually take this and you actually do one setup, that is 6.328 crude oil. Now, a full line of crude oil is going to be 300. So if we take 300 and divide that by 6.328, that is going to come out to 47.40. So if we change this to 47.41, I think it's 41. Yeah, because the 8's going to make that, yeah, so 41. And we hit enter. So that's going to be 300 crude oil, 66 iron ore, and that's going to produce 180 iron plates per minute. Now, of course, you're going to need all these different, machines and everything. So you're going to need, let's see, that's 3 refineries, another 3 refineries, so 6, plus 8 refineries, plus another 3 refineries, plus 2 refineries. So let's see, take that 2 plus this 8 makes 10. And you have 3, 3, and 3, so that's going to be 9. So you have 19 refineries, 1 foundry, just one foundry, and you have 12 assemblers and then 50 assemblers. Actually, honestly, that's not that bad. That won't even use that much power. But this is probably the least amount of product that you would need to make over 180 iron plates per minute. But that's going to be it for today, guys. I hope you enjoyed this lovely little demonstration and this nice little tutorial. I hope you build this in your world. Let me know how it goes, if you found a better design, if you thought of some cool way. And the reason why I don't do any big designs with stuff like this is because all of them tend to look the same, where it's just a giant box filled with machines. So that's going to be it for today. Don't forget to leave a like, comment, and subscribe if you haven't been subscribed yet. And join me in the next one, where I start building rotors. Anyway, guys, have a good one. I'm out of here. Bye.